And welcome to the launch of another Electron mission, our 6th for the year and the 64th launch overall. The time is just after 8 p.m. local time, and we are now just a few minutes away from liftoff from Rocketlab Launch Complex 1 in New Zealand. And tonight's mission is called the Sea God Seas, our latest launch for Japan-based Institute of Kyushu Pioneers of Space. Thank you for joining us. My name is Muriel Baker.
And I'm Andrew Haig, and we're thrilled to have you here to watch Electron take to the skies again for our latest small-sat dedicated mission. Now, the Electron rocket that you see on your screen will soon lift off for our third overall launch for IQPS and is heading to a 575-kilometre low Earth orbit. Now, IQPS is using Electron to help build out their Earth observation constellation that will provide persistent monitoring of Earth at specific fixed points every 10 minutes.
Each IQPS satellite uses synthetic aperture radar, a type of radar technique that measures the amount of signal that bounces back from the Earth's surface to create images. And while tonight's mission is our third for IQPS, it is the second this year in a series of 8 launches that will be flying to help build out that constellation. So let's hear more about their mission from IQPS.
QPS SARP
IQPS, we have launched the Moon God Awakens, the Lightning God Reigns, and now the Sea God Sees. And these mission names all reference the gods of Japanese mythology that IQPS satellites are named after.
Now, the QPS SAR-10 satellite on board tonight's mission is named Waratsumi-1, named after a great Japanese kami of the sea. Now, since this spacecraft will be tasked with observing maritime areas known for sea ice. Deployment of Waratsumi-1 will enable IQPS to provide crucial information to its customers for safe maritime navigation.
All right, we are coming up on 12 minutes away from liftoff for IQPS, but before we get to launch, first our launch operators need to make their way through the go, no-go poll to proceed with the countdown to launch. So right now they're on console in two places, Mission Control in Auckland, New Zealand, and in Range Control at the launch site, which sits around 3 kilometres back from where Electron is prepared on the launch pad. So let's listen in to hear what these operators have to say about the status of today's launch, led by Launch Director Michael Pearson.
All stations LD on mission, proceeding with the go, no go sequence. Stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCon.
VCon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
LD sub.
LD subs go.
Okay, all stations, the go, no go sequence is complete. We are T minus 11 minutes, 11 seconds, and counting. We are go for terminal count auto sequence at T minus 10 minutes. From this time, the 3-word procedure is in effect.
All right, we're cleared for launch with greens across the board from our launch operators for that go, no-go poll. Now we're aiming for liftoff right at the top of the launch window when it opens in 10 minutes, 48 seconds. But if we need to delay for any reason, today's window extends for 60 minutes to try again. Now, otherwise, T0 is set for liftoff at 8:17 p.m. local time or 08:17 UTC.
Now, while we're about to send today's mission to space, it was only days ago that we brought another mission back from space with our Pioneer spacecraft. So earlier this week, our latest 4 VADA completed some highly complex maneuvers in space that returned their in-space manufacturing capsule back to Earth in South Australia, the 3rd time that we've done this for the W-series missions. So here's more from the team behind the mission.
The W2 program is a joint program between
3 for 3 with our Pioneer spacecraft. How good.
And our team is hard at work wrapping up integration and testing for our fourth and final Pioneer spacecraft in the Varda contract in Long Beach right now. So before you know it, we'll have another Earth re-entry mission operating in orbit with our spacecraft.
Ready? LD stage on mission.
Stage LD.
The stage terminal checks are complete.
Copy, thank you.
Stage 1 and Stage 2 high voltage batteries ready for flight.
One of the most important launches set to take place this year will be the inaugural liftoff of our medium-lift reusable rocket, Neutron. And the momentum is really building as we race towards our date with the launch pad, with plenty of progress made in proving out our new rocket's design, operations, and readiness for launch. Now, our second stage is fully qualified. The upper section is almost complete too, and Neutron's launch site on Wallops Island, Virginia is almost ready for its ribbon-cutting ceremony. So let's check out some of that progress to date.
So we're gonna open in 10 seconds time.
It sounds so cool, but the countdown is on and we are so excited for Neutron's debut launch, on track for liftoff before the end of this year. But for now, back to today's mission. So we're now in the final moments of the countdown to liftoff for Electron. From T-minus 2 minutes, you can expect to hear a number of calls from our launch operators. The first call is to confirm that Electron is on internal power, and that means the rocket is running off its own batteries instead of drawing from the umbilical. And that call out also means that Electron's flight computer has taken over the countdown and is running through the checklist autonomously. Now, the next call out will talk about AFTS, or our Autonomous Flight Termination System. The operator responsible for it will confirm that it's been enabled for flight, which is a critical element that supports launch safety.
After that, we can expect to hear confirmation that loading of Electron's liquid oxygen propellant is complete and that the system is in recirculation inside the vehicle. Now, because oxygen can self-pressurize when it's in a liquid form, there are relief valves on Electron that open to prevent overpressure. And because of that, you can sometimes see that pressure relief in the form of white puffs near the top of the rocket. At about the 1 minute mark to liftoff, another call out you'll hear is that anti-geysering has been disabled, which also relates to the liquid oxygen propellant. And it's another indication the team is in the final phase of launch preparation before liftoff.
Now, soon after that will come the call out that Electron's tanks are pressed for flight. That means the system is fully pressurized and is now ready for launch. Then you'll hear that high flow engine purge is enabled, and that refers to the procedure of flushing gas through the propulsion system to make sure Electron's engines are ready for a clean start at ignition. And next we'll get a reminder of where the countdown clock is at, usually around 20 seconds to launch, before the launch director speaks again to count us down to liftoff from T-minus 10 seconds.
So, with the clock now at 3 minutes and 33 seconds and counting, all of that is coming up shortly. So let's listen in to Mission Control for the final moments ahead of liftoff, and we'll be back with you soon.
All stations LD on mission. From now, there should be no red flags on your critical LCCs. Vcon LD mission.
LD Vcon.
Lock auto sequence and confirm.
Confirmed, auto sequence is locked.
And confirm all flight computer ASGOs are green.
Confirmed, ASGOs are green.
Okay, all stations, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
The vehicle is fully on internal power. AFTS is green and enabled for flight.
LOX load is complete. System is in recirculation. Anti-geysering is disabled. Stage 1 and 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Stage 1 propulsion nominal.
And there you have it. Our 64th mission, the Sea God Seas, has left the launch pad and is on its way to orbit. Now keep listening in, because soon we should hear the GNC team give the call out that we've cleared max Q. As the rocket gets faster, the dynamic pressure builds, but as it climbs higher, the atmosphere thins. So max Q is the period where the peak aerodynamic pressure that Electron experiences as it continues onward to space.
Watching max Q. Cleared max Q.
We've just got confirmation we have successfully cleared max Q, and Electron is now travelling at over 2,000 kilometres an hour, past an altitude of 19 kilometres and climbing. And coming up next is MECO, otherwise known as Main Engine Cutoff, and this is where all 9 of the Rutherford engines that are nestled in Electron's first stage shut down before stage separation from the second stage.
Now, after that, the second stage will light up its Rutherford engine, and the mission will continue with the IQPS payload onward to orbit. And let's listen out for those calls.
Stage 1 propulsion holding nominal. Stand by for MECO in roughly 30 seconds.
"15 seconds to staging."
Entered burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
Electron has sailed through MECO with the mission now at over 90 kilometres above Earth and travelling at more than 7,000 kilometres an hour. And up next, we will have fairing jettison. So up until now, the protective nose cone that shields the payload from the harsh conditions of launch will soon be jettisoned in preparation for payload deployment. So keep your eyes sharp and see if you can spot those fairings falling away on the screen.
Fairing jettison confirmed.
And there it is. Those fairings have now been jettisoned, and IQPS's SAR satellite has officially been exposed to space. Everything's looking great so far for the Sea God seas.
HVP discharge holding nominal.
All is tracking nominally so far as we have now breezed through liftoff, max Q, MECO and fairing jettison. And we can see that the single but mighty Rutherford engine is burning brightly as ever as it propels our second stage and the Waratsumi 1 payload to orbit.
Now you can see the glowing red nozzle of our Stage 2 engine on screen right now. The Rutherford engine that we use on our second stage is almost exactly the same as our Stage 1 engines, but they work in very different conditions. Our second stage engines are built for in-space propulsion, so we have to make sure that they can cool themselves down since it gets extremely hot without the help of convection when they're in the vacuum of space. They also feature an expanded nozzle, which is used to maximize the thrust of the rocket engine, converting more of the thermal energy into kinetic energy and improving the overall performance. Now, next up, we have the battery hot swap to look forward to. If you've tuned into our previous launches, you might be familiar with this unique event that happens with Electron. Now, during the second stage burn, the batteries that power the Rutherford engine will soon be depleted, so we need to swap them for a new set.
That's right. Now, that switchover is called the hot swap because the engine remains ignited. And we'll know it's been successful when we hear the call out from Mission Control. And if we're able to see those batteries fall away from our view from Electron's onboard camera. So let's tune into Mission Control and listen out for that call.
Throttling down.
Battery jettison confirmed.
It's always a big moment for the team there. Battery hot swap confirmed. Now, hopefully you're able to spot those batteries fall away. We're now traveling at 15,000 kilometers an hour at over 243 kilometers in altitude. There's still 2 minutes left in the flight for IQPS, but Electron and its payload remain healthy and all is continuing nominally.
We are now over 7 minutes into the mission and at an altitude of over 250 kilometres. And Mission Control is continuing to monitor the vehicle as it prepares to part ways with its second stage. So they're looking at a wide range of systems from propulsion of our Stage 2 engine, function of our ground stations, ensuring our trajectory remains on track and that the payload remains healthy. Now, SECO, or second engine cutoff, is fast approaching, and similar to main engine cutoff, SECO involves throttling down and eventually shutting off the single Rutherford engine on that second stage. This will be followed by the kick stage's separation from Stage 2, and we will know SECO is imminent when we hear Mission Control announce Enter Burnout Detect Mode. Standing by now.
SECO confirmed.
Stage separation confirmed.
Nominal transfer orbit achieved.
And there it is. We've just heard Mission Control confirm SECO and kick stage separation. It's another perfect orbital insertion. And with the kick stage now successfully separated, IQPS's SAR satellite now enters a coast phase around Earth before the kick stage lights up with an engine burn to place it into a circular orbit for payload deployment. We're aiming for a 575 kilometre altitude for that deployment, set to take place in about 40 minutes' time.
We're not done yet, but for now, we'll take a quick break while we cruise over South America and the Atlantic Ocean. And Andrew and I will see you back here soon.